All right, guys, last set of notes for this section, just for fun, because, breaking it up midweek. If you can email me a picture of yourself either outside in the sun with a thumbs up, or a picture of you in a sweatshirt or a t-shirt or a hat wearing, the school that you are committing to maybe. Or a third option could be you with a pet. Then I will give you a bonus point on something. So if you are watching this on time, I'm only doing this for those of us who are doing this by midnight of the night assigned. If you email me a picture of yourself in one of those 3 scenarios, you got a bonus point. Congrats. Get excited. That's fun. On something. I don't know what yet. All right. So we are going to integrate e to the x now. So the nice thing is that the derivative of e to the x is e to the x. So the integral of e to the x is e to the x plus c, right? The other thing to be careful of is that if you integrate something different than just e to the x, you have to multiply by your u. So turn this into your derivative, so this is really the same thing as u prime, okay? Same idea. All right, so we're starting off pretty tough because it's not just a standard, like if I gave you 2e to the x plus c, or just 2 to the x, it would be e to the x plus c, which is convenient. But in this case, we want to recognize that e is being raised to something different. So I have to use u substitution. So exciting. So u is x squared, which means du is 2x dx. Oh, convenient. It's right there. So I'm literally integrating e to the u du, right? Because that is what du is. It's the remaining piece. The integral of e to the u is literally e to the u plus c. Now I just have to sub back in. So it's e to the x squared plus c. And that's my answer. If you are like really good, you're feeling super confident, you can skip right from this step to that if you would like to. Okay, just be careful. Don't go too quick because that's where you start to mess things up. All right. The next one, we are going to have to take out a value because what you'll notice is that our u is 3x minus 5, which means du is 3 dx, and there's no 3 in the original. So I actually have to divide that out. And again, if some of us want to jump straight to the answer, it's 1/3 e to the 3x minus 5 plus c. All right, next up, 7 e to the negative 3x. Try it. Hopefully you get what I get. It's a little bit more complicated because there's a fraction, but most of us, I think, should be good. All right, how many of you got negative 7/3 e to the negative 3x plus c? Woo, so exciting. If you didn't, you can either factor out the 7 from the beginning if that helps. So like that's what I did here. Or you can factor just out the negative 1/3. Because if you have negative 3 in your du and it's not in the original, you need to divide it out. Okay? All right, next up, we got a few more to try. And then we'll do some definite integrals. Some of us tried to use our calcs on the quiz on that. No. You got to show some calculus first. Be careful. Okay. First thing to notice here is that we got a lot going on. But also, your 1 over x is going to be your u, which actually helps us because du, if you remember, this is the same thing as x to the negative 1, is negative x to the negative 2. That is the same thing as negative 1 over x squared, which is actually here minus the negative, right? So now I can integrate negative 1, factor that out, e to the u du, And then it just becomes negative e to the 1 over x plus c. Trig, dun dun dun. Don't worry, it's not bad. U is cosine. Du is negative sine, right? Dx. I forgot my dx over here, sorry. So this is really the negative integral of e to the u du. Ba, ba, ba. So your answer is negative e to the cosine of x plus c. If I'm going too fast, I'm sorry. Join my office hours, though. All right, definite integrals, same thing, except you plug in the values like we're used to doing. So it's really not different from the norm, which is nice and convenient. Okay, so let's do the first one together. And then I will have you try the second one. We'll see if you can. We'll figure it out together. All right, so my hint here is I would say, because there's something going on in parentheses, u should be e to the x. But what? That's because you know the integral of cosine. So du is e to the x dx. Aha, that's right here. Cool. So I'm going to integrate between negative 1 and 0. Cosine of u du. And the integral of that, that's right, it's sine of u, if you forgot that. Some people forget it, which is fine, it happens. And then you're going from 0 or negative 1 to 0. So you're actually integrating sine of e to the x from negative 1 to 0. You guys have done this a zillion times at this point, so plug in 0, plug in 1, subtract your answers. So sine of e to the 0 minus sine of e to the negative 1. This is a calculator type question. And you end up with 0.482, just so you know. If you want to try it out, you can, but you know, you should. All right. Next one. Go for the more complicated part here. Which one should be u? Well, neither, because it's math, but you know what I mean. Sorry, I'm being so weird today. U equals 1 plus e to the x. Du then is going to be e to the x. Oh, that's convenient, because that's on top. Sweet. So just be careful, because now you're integrating from 0 to 1, 1 over u du. Now, hopefully, we all remember the integral of 1 over u du from the last unit. So pause the video, try it. Hopefully you get it. I really hope, because we've done it a lot. Okay, so you end up with ln of absolute value of u between 0 and 1, which is really ln absolute value of 1 plus e to the x, because that's u, between 0 and 1. Ln of 1 plus e to the 1 minus ln of 0, oh no, that's still 1, sorry, of 1 plus e to the 0. Put it in your calculator. It's 0.62. Sweet. All right, last two pages. Okay, again, millionth time we've done this, but with now e to the x. So find the area between y equals 0, x equals 0, x equals 5. What does that look like? 0 to 5, right. E to the negative x dx. Okay, so integrate that. You end up with negative e to the negative x, which is the same thing as the derivative of it, which is kind of cool. Between 0 and 5, plug in negative e to the negative 5 minus, which turns into plus because it's a negative, e to the 0, which is really like negative e to the negative 5 plus 1, because anything to the 0 is 1, but anyway, 0.993. Dun, dun, dun. All right, last question. I'll get you out of here real fast. Get you out to do other stuff for school or not school. All right. Find the particular solution that satisfies the initial condition. So what this means is we need a second derivative that gives us this. And then they give us points. Haha, hopefully you remember how to do this. But I'll do the first part with you, and then I want you to try the second. So if I were to find a particular solution, I want to look for f of x is what they're actually asking you to find. So let's start with finding f prime of x. So I'm integrating this, right? Whoops, I should probably rewrite that. Integral of sine of x plus e to the 2x. Cool. All right. So that's going to equal, what's the integral of sine of x? Negative cosine of x. Plus the integral of e to the 2x. If you need to do it off to the side, feel free, but the integral of e to the 2x, if u was 2x, that means du is 2. There's no 2 here, so I have to write it as 1/2 e to the 2x, right? Plus c. All right, so there's my f prime of x. If that was too fast, I apologize. All right, so we're going to plug in the point. But which point do we plug in? That's right, this one. It's saying f prime of 0 is 1/2. So f prime of 0 is 1/2. That means I'm plugging in 0 for x. 0 plus c. So I can solve for c, right? When you're all done that, and you solve for c, just so you know, c equals 1. So now I'm integrating to get my original function. I need to integrate f prime of x, which is negative cosine of x plus 1/2 e to the 2x plus 1, because that's what I got for c. All right, do it again, then plug in the other point, and you'll have your original function back. All right, folks, final answer is negative sine of x plus 1/4 e to the 2x plus x, because you get c equals 0 if you plug in the point 0, 1/4. If you had trouble with any of this, please feel free to join my office hours or email me with questions. Have a great rest of your day.